This is the last section in Chapter 9, which is dealing with solving rational equations. So as we've gone through this course, what you've kind of noticed is we work with different types of functions, and by the end of the chapter, we use techniques to solve. And that's exactly what's happening here. We're finishing with solving. There are 3 different types of solving problems that you should be able to do. The first type is being able to solve by cross-multiplying, which is what this first screen is going to go through. Probably the most basic solving, what you would have done in Algebra 1. And then we're going to go through solving where we are clearing fractions. That's going to be the next slide, which is a little more involved. And then we're going to finish with solving rational equations that are complex. And that is actually something that we only covered in the honors. So when we get to that point, I will let you know if it's something that you need to keep watching. So what we have here, we have a proportion. If you remember from geometry or from algebra, anytime you have a fraction equal to another fraction, we refer to that as a proportion. And the easiest way to solve that is to cross multiply. So we multiply across, so 2 times x plus 1 equals negative 5 times x minus 6. Now, if you can distribute as you go and you don't need to write this line, that's fine. But I do write it like that just to remind me that I have to distribute. So I get 2x plus 2 equals negative 5x plus 30. I'm going to solve this, just any linear equation solving here. So I'm going to subtract 5x, so I get 7x plus 2 equals 30. Subtract 2, 7x equals 28. Divide by 7, and we get 4. Now, something that we talked about in this section is you do have to check your answer at the end to make sure it's not extraneous. What makes an answer extraneous when we're working with rational equations is if the x value that you get makes any of the denominators in the original problem 0, we refer to that as extraneous, because we've talked throughout this chapter that you can't have 0 in the bottom. We used it when we found domain, when we found asymptotes. So if you take this number, we get x equals 4. If you put it into the first fraction, make sure the denominator is not 0, which it's not. And then if you put it into the other fraction, make sure that denominator is not 0, which it's not. So in this case, no problem. And you don't have a lot of extraneous, but it is something you want to check every time you finish a problem. This one is also a cross multiplying, and we do have to distribute. So we're going to have x, sorry, my pen's going a little crazy, x times x minus 1 equals x minus 5 times 2x plus 7. I'm going to distribute on the left, so I get x squared minus x. On the right, I have to FOIL, so my first is going to be 2x squared. My outer is 7x. My inner is negative 10x, so 7 minus 10 is negative 3x. And my last is negative 35. I want to get in standard form, so I'm going to move everything to the right. So I'm going to subtract x squared and then add x. So I get 0 equals x squared minus 2x minus 35. Factor it to get my solutions. It's an x plus and an x minus. To get 35, it's 7 times 5. I need the 7 to be negative, so we have more negatives. So my 2 answers are x equals negative 5 and x equals 7. We want to make sure that both of those can be plugged back into either the denominators. So if I put negative 5 into the first denominator or the second, no problem. If I put 7 into the first denominator or the other denominator, no problem. Second type of problem that we ran into here was not a proportion. Now you'll notice it's not just a fraction equal to a fraction. We have multiple fractions on one side or the other, or both. When that happens, what we do is called clearing fractions. We identify the least common denominator, the LCD, just like we did in the last couple days worth of material, but we use it a little differently here. So here we have a denominator of a 2x and a denominator of a 2. The LCD would be 2x. What we do to clear fractions is we're going to multiply every term by that LCD. So every term gets multiplied by 2x. A term is anything separated by an addition or subtraction sign. So every term gets multiplied by 2x. We're going to see what cancels and what's left. So the 2x divided by 2x cancels. We're left with just the 3. The 2 and the 2 cancel. We're left with a minus 9x. Nothing cancels on the right because there is no denominator to cancel with. We get 12x squared. I'm going to get everything on one side. Again, I'm going to go to the right because I like my first term to be positive. Makes it easier to factor. I'm going to add 9x and then subtract 3 so I get these terms to come over. I'm going to factor out a 3, giving me 4x squared plus 3x minus 1. And then I am going to factor, I know it's got to be a 1 and a 1. I know it's got to be a plus and a minus. To get 4, it's either going to be 2x times 2x or 4x times 1x. To get the right middle term, I need it to be 4x times 1x. So I need this to be 4x and this to be 1x so that I get a 4x here and a negative x there. My 2 solutions then are x equals negative 1 and x equals 1/4. That comes from got a dead zone here, sorry. Negative 1 and 1/4. Take those two solutions, plug that back into the denominators. Notice the only denominator I need to check here is this one because it's the only one that actually has a variable in it. When I plug them in, I don't get 0 in the denominator, so they are not extraneous. And then the last one, last one in this type, in order to identify the LCD, I need to factor this denominator. It factors x plus 3x minus 3. That means the LCD, looking at these two denominators, is x plus 3x minus 3. So I'm going to multiply everything, every term, by x plus 3x minus 3 to clear fractions. When I do that, on the left side, the x minus 3's cancel. So I'm left with 2x and x plus 3, which I'm going to distribute in a second. The entire denominator here cancels with everything here, so I'm just left with the 3x that was in the numerator. And nothing's going to cancel here, so I'm going to have 2 times. When I multiply x plus 3 and x minus 3 back together, I get x squared minus 9 when I FOIL it out. I'm going to distribute, so I've got 2x squared plus 6x equals 3x plus 2x squared minus 18. The 2x squareds will actually cancel when I subtract 2x squared on both sides. I'm going to subtract 3x over here, so I get 3x equals negative 18. Divide by 3, I get x equals negative 6. Plug it back in, make sure I don't have any extraneous solution here, which I don't. So what you'll notice is I did 4 problems. I didn't have any extraneous solutions. That doesn't mean I shouldn't continue to check, because it is very quick to check, because you will have problems. We did some in class, we did some in the homework that do have that potential of having extraneous solutions. The last problem I want to go through is an honors-only problem. This is not something that I went through in the regular class, so if you are in the regular Algebra 2 test class getting ready for your test, you can stop the video now or go back and look at some of the previous ones to make sure you know what you're doing. If you are taking the honors test, you must know how to do this last type of problem, which is a rational equation that has complex fractions on one of the sides. This is essentially going to combine the last 2 lessons that we did in class. How do we simplify a complex piece, which was what we did in 9.5, and then how do we solve when we're done with that, which is what this section is dealing with. When you have a problem like this, you want to focus entirely on the complex side first. You want to look at the complex side and identify the LCD. So right now we have denominators of x and x plus 1, so that is my LCD. We're going to multiply every term on the complex side by the LCD. So by x, x plus 1, x, x plus 1, and x, x plus 1. Notice the side that was not complex, the 2, is not changing. Nothing happens with it. I'm not going to even deal with it until I'm done simplifying the complex side. I am multiplying by x, x plus 1 on top, and x, x plus 1 on the bottom. Cancel and see what's left. So my x's cancel, I'm left with x plus 1. My x plus 1's cancel. I'm left with a minus x, because I have 1 times x. And my x plus 1's cancel. I'm left with x. My x's cancel, so I'm left with 1 over x. Very simple at that point. Now reintroduce the 2 that's been there all along, but you haven't really dealt with it yet. Once you get to this point, to finish this problem, it will always be a cross multiplying. You do all the simplifying with complex from 9.5 to get it to be a nice single fraction, and then when you are done, you set it equal to whatever was on the other side, and you are ready to cross multiply to finish it off. So we get 2x equals 1, divide by 2, we get x to be a half. We still want to make sure that we can plug a half into all the denominators, which we can, so it is not extraneous. And this is the last type of problem that you have to be able to do. So to kind of recap, in 9.6, you have to be able to solve a proportion by cross multiplying. You have to be able to solve a more complicated rational equation by clearing fractions, multiplying by the LCD. And then in the honors class, you have to be able to solve a complex rational equation by first simplifying the complex piece, multiplying by the LCD in every term, and then finishing the problem by cross multiplying. If you can do all of these problems, you will know exactly what to expect and be able to be successful on the Chapter 9 test.